So, very good morning to all. Welcome to this special lecture on contemporary developments in physics, in particularly artificial intelligence. We will talk about the Nobel Prize in Physics awarded to John Hopfield and Geoffrey Hinton in 2024. So, before that, I'll be thankful to the competent authorities of Amity University, Bangalore and Ritnan Balwed Education Foundation. Our founder president, Professor Dr. Ashok Chauhan sir, our Honorable Chancellor Asim Chauhan sir, our Vice Chancellor Professor D. Shubhakar sir, our Vice President RBEF Professor Sali sir, our Pro Vice Chancellor Professor Monit Kapoor sir, all the head of the department, head of the institutions, directors, and other office bearers of this Amity University, Bangalore. So this is a special event for all of us, where at the end of the semester, you people have learned physics in this first semester. You might have studied the introduction to the quantum physics as well as some of the applications in the modern technology, such as optoelectronic devices, the lasers, optical fibers, and so on. In continuation of these fundamentals that we have studied, we will now, in today's lecture, we will look at how artificial intelligence is used, the concepts of physics in developing the neural networks. So before that, we'll just have a quick look at the history of the Nobel Prize. The person here is Alfred Bernard Nobel, who is a chemistry person, chemist. Later, he became an entrepreneur, inventor, businessman, and author. He wrote many books. He invented dynamite and holder of 55 patents. As you all know, the dynamite is an explosive. So he written a will leaving 31 million Swedish nor as a fund to give these Nobel Prizes. So here is just one image, the testament that he has written in Paris on 27th November 1895. He specified all this bulk of his fortune should be divided into 5 parts. Is to be used to give the prizes in physics, chemistry, physiology or medicine, literature, and peace. You can ask me the question, sir, why there is no prize for mathematics? Mathematics is the language of science. Like we use the English to communicate with each other, in order to understand this physics, chemistry, physiology, medicine, all these needs a language, which is mathematics. Okay, so that is the reason. So mathematics is everywhere. It's not a the specific discipline, right? It's a natural science. So those who do, for whom this Nobel Prize will be given, right? For those who are made a substantial contribution to the any of this field in the preceding year. So they will be conferred with the greatest benefit to the humankind. So this is one of the most prestigious and the topmost award in the field of science and humanities that is being considered across the globe. So coming to the Nobel Prize in Physics 2024, this is a press release. John Hopfield and Geoffrey Hinton. These two people, one from USA, Princeton University, Professor Hinton from the Toronto, University of Toronto, Canada, right? So they both have been jointly awarded. They shared the prize equally for the foundational discoveries and inventions that enable machine learning and artificial neural network. So I used to tell in almost my class, right? So physics, computer science, artificial intelligence, machine learning, all these are all interrelated. If you are strong in mathematics, you can be good at physics. If you are good at physics and mathematics, definitely you are going to be good at your programming, coding, as well as in the R&D in the field of computer science and engineering. So this year, two Nobel laureates in physics have used the tools from physics to develop the methods that are foundations of today's peaceful machine learning, powerful machine learning. So John Hopfield created an associative memory that can store and reconstruct images and other type of patterns in data. So Geoffrey Hinton invented a method that can autonomously find the properties in data and perform tasks such as identifying the specific elements in a picture. So we talk about artificial intelligence, we often mean machine learning using a artificial neural network. This technology was originally inspired by the structure of the brain. And in an artificial neural network, the brain neurons are represented by nodes that have different values. So these nodes influence each other through connections that can be linked to the synapses and which can be made stronger or weaker. The network is trained, for example, by developing a stronger connection between the nodes of the system with simultaneously higher values. So this year, Nobel laureates have conducted important work with artificial neural network from 1880 onwards. It is not that one day or 2 day discovery, right? It's about 50, 40, 50 years of continuous effort made them to get this prestigious Nobel Prize. So here is just a brief introduction to the John Hopfield. So he born in July 1933 in Chicago, Illinois, USA. Affiliation at the time of the award with the Princeton University, New Jersey, and prize for motivation for foundational discoveries, right? And invention that enable the machine learning with artificial neural network. And he invented this network that uses the method for saving, recreating the patterns. We can imagine the nodes as pixels. The Hopfield network utilizes the physics that describes the material's characteristics due to the atomic spin, a property that makes each atom a tiny magnet. I used to tell in my regular class, spin need not be considered as a leg spin or off spin in a cricket ball or an electron moving in an right clockwise direction or anti-clockwise direction. No, it is purely quantum mechanical concept, right? So which has the magnetic property. So this network as a whole described a manner equivalent to the energy in a spin system found in physics. So which is trained by finding the values that connect between the nodes that has saved the image have the lower energy. When the Hopfield network is fed to the destroyed, distorted or incomplete image, it methodically works through the nodes and updates their values so the network energy falls. The network thus works stepwise to find the saved image that is most like the imperfect one which was with fed with. And Geoffrey Hinton, he affiliated to the University of Toronto in Canada. He born in 6th December 1947 in London, United Kingdom. So for the same, okay. So these two people have jointly won the Nobel Prize, and whatever the prize money was there is equally shared. So he used the Hopfield network as a foundation for the new network that uses a different method called Boltzmann machine. So this can learn to recognize the characteristic elements in a given type of data. Hinton used a tool from statistical physics, the science of the system built from many similar components. This machine is trained by feeding it examples that are very likely to arise when the machine is run. Also, machine can be used to classify images to create new examples of type of pattern, which is the Hinton has built upon this network, helping initiate the current explosive development of the machine learning. So now let's try to understand some of the basic physics as well as how this physics has been applied to this artificial neural network and artificial intelligence, right? So now many people have experienced how computers can translate between languages, interrupt the images, and even conduct the reasonable conversations, right? So what perhaps is less known is that this type of technology has long been important for research, including the storing and analysis of vast amount of data like the cloud. The development of machine learning has exploded over the past 15-20 years and utilizes a structure called artificial neural network. Nowadays, we talk about artificial intelligence. This is often a type of technology we mean. Although computers cannot think, machine can now mimic the functions such as memory and learning. So this year, these two people make it possible that the machine can mimic the function, they can think, and they can store the memory using the fundamental concepts and methods from physics. We have developed these technologies, the structure into the networks processes the information. This machine learning differs from the traditional software, as you all know, right? So this works like a recipe. The software receives the data, which is processed according to a clear description of the and produces the result. Much like the someone collects the ingredient and process them by following a recipe, making a cake. For example, if you want to cook a cake, you know the ingredient, you know the recipe, then you can cook. So, like instead of this, the what machine learning in the computer learns by example, right? Enabling it to take problems that are too vague and complicated to be managed by step instructions. One such example is interrupting a picture to identify the objects in it. So to mimic a brain, so what is this artificial neural network, right? So this process information using the entire network structure. The inspiration for this artificial neural network came from the desire to understand how our brain works. In 1940s, researchers have started to reason around the mathematics that underlies the brain's computer network and neurons and synapses. Another piece of puzzle came from the psychology, thanks to the neuroscientists, okay? So who gave this hypothesis about how learning occurs because the connection between the neurons that are reinforced when they work together. Later, these ideas were followed by attempts to recreate how the brain's network functions by building artificial neural networks as computer simulation. So these brain's neurons are mimicked by the nodes that are given different values, and the synapses are represented by connections between the nodes that can be made stronger or weaker. So at the end of 1960s, some discouraging theory results are caused many researchers to suspect that these neural networks never be of any real use, right? So, however, interest in artificial neural networks were further reawakened in 1980s. For about 20 years, almost people didn't talk about these neural networks. But again, regarding the artificial neural network has started, several important ideas have been made, right? That can be used in today's work. Now, we'll just little bit talk about the associative memory. What is this associative memory? So to understand this concept of associative memory, you imagine that you are trying to remember a fairly unusual word that you are rarely use. For example, the one for that sloping floor often found in the cinema halls and lecture halls. You try to search in your memory something like a ramp, no, perhaps radial, no, not that. A rake, yes, that's it. Okay, so this is how this process of searching through the similar words to find the right one is more reminiscent to that of the associative memory, right? So that is the physicist John Hopper discovered in 1982. So this half-filled network can store patterns, can has methods to recreate them. When the network is given an incomplete or slightly distorted pattern, this method can find and store pattern that is most similar. Hoffield has previously used his background in physics to explore theoretical problems in molecular biology. He was invited to meeting, right? So in a neuroscience conferences, he encountered research into the structure of the brain. He was fascinated by what he has learned and started to think about the dynamics of simple neural networks. When neurons act together, they can give rise to the new and powerful characters that are not apparent to someone who only looks at the network separately. Okay. However, he did not abandon his ideas of the foundation of physics, where he found inspiration for his further understanding of how systems with many small components that work together can give rise to the new interesting phenomena. He particularly benefited from having learned about the magnetic materials that have special characteristics thanks to their atomic spin, right? A property that makes each atom a teeny magnet, right? So spin of the neighboring atoms affects each other. This can allow domains form with the spin of the same direction. As you say, the direction here represent the energy state associated with the particle. Was able to make a model network with nodes and connections using the simple physics that describes how material develop when the spin influences the other. So when the network saves the images in the landscape, what does it mean? So whatever the network that Hopfield built has the nodes that are all joined together via connections of different strength. Each node can store an individual value in Hopfield first work. It could be either 0 or 1, like the pixel in black and white picture. Hopfield described overall state of the network with a property that is equivalent to the energy in the spin system that found in physics. The energy is calculated using the formula that uses all the values of the nodes and all the strengths of the connection between them. Open network is programmed by an image being fed into the nodes, which is given the value of 0 or 1, that is black or white. The network connections are then adjusted using the energy formula that is saved image to get the low energy. So here I want to recall in your particle confined in a infinitely deep potential well, right? So you all derived an expression for energy eigenvalues, right? So which is given by E is equal to n square h cross square pi square by 2 ma square. This n characterizes the energy state of a given particle. This n cannot be zero. So when n can be zero, when there is no system exist. When n can be one, it has a particular energy state. So there is nothing in between. So this basic concept is used, right? So in storing the images in the pixel in the terms of black and white. This may not appear so remarkable, right? So the connections with another pattern fed into the network. So there is a rule for ongoing, right? Through the nodes one by one by checking whether the network has the lower energy if the value has the node that is changed. If it turns out the energy is reduced by a black pixel instead of it changes the color. The procedure continues until it is possible to find any further improvement. When this point is searched, the network has often reproduced the original image on which it is trained. Okay? So this is also like a kind of associative memory. So this may not appear remarkable if you save only one pattern. Yeah? You are wondering why you don't just save the image itself and compare it to the another image being tested. But Field method is special because several pictures that can be saved at the same time and the network can be usually differentiate between them. To understand this, we can have a look at this image, right? So searching for a network of a saved state to a rolling ball through the landscape of the peaks and valleys with friction that slows down this movement. If the ball is dropped in a particular location, it will roll into the nearest valley and stop there. If the network is given to a pattern that is close to one of the saved patterns, it will, in the same way, keep moving forward. It will end up the bottom of the valley in the energy landscape, thus finding the closest pattern in the memory. The off-field network that can be used to recreate the data that contains the noise and which has partially erased. Field and others have continued to develop the details of how and the how-field neural network functions, including the nodes that can store any value, not just 0 or 1. See, this is where they found the right, innovation or the invention. Okay, it need not be the 0 or 1. The other possible states are also to use in the artificial intelligence. If you think about the nodes as pixels in picture, they can have different right colors, not just black and white. Improved methods have made it possible to save more pictures and to differentiate between them even when when they are quite similar. It is just possible to identify or reconstruct any information at all powered by it to build from any data point. Now, so before talking about further recognition of the new examples of same type, let us just quickly recall the 19th century physics. That is basically remembering an image is one thing, but interpreting what it dissipates requires little more. For example, when we are all young children, we are looking at different animals and confidently say, oh, it is a dog, it's a cat, it's a squirrel, it's an elephant. Like that, whatever the name that we know, we used to say. Then the moment we came to know that, oh, it looks like a cat. No, no, it's not a cat, it's a cheetah, right? No, it looks like a dog. No, it's a hyena. Correct? No? So, like this, we can fairly correct almost the things that what the errors that we have made without any explanations. So similarly, each of these different categories falls into our head, right? We can learn, recognize a given animal or to understand a word or to enter a room or to notice something that has changed by experiencing the environment around them. Okay. So when Hoffield publishes this article, right? So in the Pittsburgh University, he had previously studied experimental psychology and artificial intelligence in the England and Scotland and had wondering why machines have could learn to process the patterns similar way to the humans. You can see he's trying to link between the physics, biology, and computer science, artificial intelligence. So the statistical physics describes the system that are composed of similar elements such as molecules in a gas. Like we are talking about the electrical conductivity chapter. In the electrical conductivity chapter, we consider that the electrons are equivalent to gas molecules. Correct? So where the Boltzmann-Maxwell statistics is applicable. Later we came to know that so these are not gas molecules, they are quantum particles. Then in that case, the Fermi-Dirac statistics can be applicable. So here, so it is really difficult or impossible to track all these separate molecules in the gas, but it is possible to consider them collectively to determine the gas as a gas overreaching the properties like the pressure, temperature, and so on. There are many potential ways for a gas molecules to spread through its volume individual spreads. The states in which individual components can jointly exist can be analyzed using statistical physics. and the probability of them occurring is calculated. One, some states are more probable than the others. This depends on the amount of available energy, which is described in an equation in the 19th century by the Boltzmann. Correct? Even in the laser physics, if you remember, we have given the laser Boltzmann equation, the population ratio N2 by N1 equal to e to the power of minus h nu by kt, the population ratio between the two states, right? So one such equation has been used in this also, right? So this Hinton's network utilizes this equation, and this method was published in 1985, right? And that name was called as Boltzmann machine. So, right? So here, so this Boltzmann machine will be used to identify the different types of the network that present, right? So which is the Boltzmann machine is commonly used with two different types of nodes. Information is fed into one group, which are called as the visible nodes. The other nodes form the hidden layer, or the hidden nodes values the connection to contribute the energy of the network whole. The machine is run by applying a rule for updating the values of the nodes at a time. Eventually, the machine will occur a state in which the nodes or pattern can change, but the properties of the network as a whole remain the same, which is possible. The pattern will then have a specific probability that is determined by the network's energy according to the Boltzmann equation. The machine stop has created new pattern, which makes Boltzmann machine as a real example of the generative model. So you people are talking about the generative artificial intelligence also. So this is the basis for that generative artificial intelligence. The Boltzmann machine can learn not from the instruction, but from being given examples. It is being trained by updating the values in the network connections so that the examples patterns which were fed into the visible nodes when it were trained have highest possible probability of occurring when the machine is run. If the same pattern is repeated several times during the training, this is probably the pattern is even higher. Training also affects the probability of overputting a new patterns that resembles the examples on which the machine trained. A trained Boltzmann machine can recognize familiar traits in information it has not previously seen. Imagine meeting a friend's sibling, right? You can immediately see that they must be related to each other. In the same way, right, the Boltzmann machine can recognize an entirely new example if it belongs to a category found in any material or differentiate it from the material that is similar, okay, or dissimilar. So it is in its original form, the Boltzmann machine is fairly insufficient to take long time find the solution. Things become more and more interesting when it is developed in various ways, which Hinton was conducted and explored. Right. So later versions have been thinned out. The connections between some of the units have been. So this turns out as many makes the machine more efficient. During 1990s, many researchers lost interest in artificial neural network, but Hinton was one of those who continued to work in the field. He also helped to start the new explosion of exciting results. In 2006, he and his colleague Simon, right, along with Yi and Rolson, developed a machine or a method for pertaining a network with a series of Boltzmann machine in layers on top of these others. So this pertaining gives the connection in the network a better starting point, which optimized its training to recognize the elements in picture. So Boltzmann machine is often used as a part of larger network. Right? Example, it can be used to recommend films or television series based on the reviewer preference. Like all these OTT platforms such as Netflix, right? And Amazon Prime, all these, they will use this at the back end, the server mode. So finally, to come to an end, what will be the state of machine learning today and tomorrow? So which is one of the important, right, to conclude this talk. So we need to be thankful for their work from 1980s, from last 40, 50 years, particularly this John Hopfield and Hilton. They helped the foundation for the machine learning revolution started in around 2010. Nowadays, we are all taking, right? The people have started interesting in artificial intelligence and machine learning. So this is not one day or 2 day effort. It is a continuous effort, right? The development we are now witnessing has been made possible through access to the vast amount of data that can be used to train it and through the enormous increase in computing power. Today's artificial networks, neural networks are often enormous and constructed from many layers. So these are called as deep neural networks. And the way they are trained is called deep learning. So in your higher semesters, these are all the courses you are going to study, right? Um, Generative artificial intelligence, deep learning. Okay, so you can remember these keywords. You can remember my name. You can remember the physics when you are going to take these courses. If you are really good at the quantum physics, right? Definitely you are going to learn your machine learning, deep learning, generative artificial intelligence. Okay, all this will be really helpful in your future. A quick glance at Hoffield's article on associative memory from 1982 provides some perspective on this development. It is used network with 30 nodes. All the nodes are connected to each other. There are 435 connections. These nodes have their values. Connections have different strengths, and total there are about fewer than 500 parameters to keep track of it. So it also tried to have a network with 100 nodes, but it was too complicated given a computer he was using at a time. Because in 1880s, okay, the computer was in the Stone Age, right? So we didn't have that much advancement in 1880. The size of the computer machine will be approximately a size of a almirah or a bureau, okay? So it's not so small like right now we have the laptops and pump tops. So we can compare this, the large language models of today, right, that are built networks contain more than the trillion parameters. Okay, 1 million, 1 trillion means like 1 millions of the millions, right? So earlier he tried with only 435 connections with the 30 nodes. Now we can have trillions of connections. So many researchers are now developing the machine learning areas of application, which will be the most viable remains to while there is also a wide range discussion on the ethical issues that surrounded the development of these use of this technology. Because the physics has contributed tools for the development of machine learning, it is interesting to see how physics, right, is benefiting from the artificial neural network. So machine learning has been long used in the areas we may familiar with the previous Nobel Prize. To take this include as an example, machine learning was used to shift the process of vast amount of data to discover the Higgs boson particle. Other applications include the reducing the noise in measurement of the gravitational waves from the collides of the black holes or for search of the exponent. These two machine learning concept has used right in these two Nobel Prize award winning concepts. In the recent years, this technology has also begun to use calculating and predicting the properties of the molecules and materials, such as calculating the protein molecular structure, which determines their function, working out on the new versions of the material, right? So which they have the properties for the use in more efficient solar cells. So this is about today's lecture. So thank you all for joining this meeting. So all the very best, right? So do well in your examination. Try to get your fundamentals more stronger and stronger study mathematics well, study physics well, your future will be brighter. If your foundations are stronger, right, definitely you are going to be a big tree which is going to give a shadow for thousands of people. You can achieve plenty of things in your life, right? So all the very best. Now, if you have any questions, you can type it in your chat box. I'm here to answer. The chat box is open to all the participants. Lokesh?
Yes, sir.
Yeah. So, students, you can just type your questions or doubts, what you have in your mind regarding today's lecture in the chat box. I will answer. We will wait for 1 minute. If we receive any questions, we'll continue. Otherwise, we'll stop. Okay. Seems to be there are no questions. Once again, thank you all, particularly my colleagues, Dr. Lokesh, Dr. Vishnu Vikesh Jaishwal, Dr. Balakrishna, the head of the Department of Computer Science and Engineering, Professor Sonalata Madam, and all other people who are involved in teaching this artificial intelligence and machine learning, Dr. Rajesh, Dr. Rajat, Dr. Shashwat, and all these people are good at this artificial intelligence and machine learning, right? So thank you all. Thank you all for joining. All the very best.
So can I close?
Yeah.
Okay, sir.
Thank you.